we have question number 61, which says that the 40% N2O4 molecules dissociates into NO2 in a sample of gas at 27 degrees Celsius and 760 torr. The density of the equilibrium mixture is. So we have a equilibrium between N2O4 and NO2. So we can write the equilibrium between N2O4 and NO2. Suppose there is initially 1 mole of N2O4 present, and after time t it will be 1 minus alpha and 2 alpha, and you have been given the 40% N2O4 molecule dissociate. It means alpha की value कितनी होगी 0.4, so it is 1 minus 0.4 and it is 2 into 0.4. So कितने हो गए मोल्स N2O4 के? It will be equal to 0.6 and NO2 के मोल्स हो गए 0.8. So now you have to calculate the density of the equilibrium mixture. So we need to apply the expression Pm is equal to dRT, where P is the pressure, that is 760 torr we have been given, and temperature we have been given, that is 27 degrees Celsius. But the problem here is the molar mass of the mixture. So first of all, calculate the molar mass of the mixture. Because the mixture contains both N2O4 and NO2, so we have to calculate the molar mass of the mixture. So it is the number of moles of N2O4 into molar mass of N2O4, that is 92, plus number of moles of NO2, 0.8, into molar mass of NO2, that is 46, divided by total number of moles, that is 1.4. So calculate this, the answer will come out to be 65.71. So this is the molar mass of the mixture. So now substitute all the values in the equation, you will get the density of the equilibrium mixture. So the density will be equal to pressure, that is 760 torr. So convert this into ATM. So in ATM it will be 1 ATM. So pressure is 1 ATM into molar mass of the mixture, that is 65.71, divided by R, that is 0.0821, into temperature but in Kelvin. So it is 300 Kelvin. So if we calculate, the density will come out to be 2.67 gram per liter. So option number 1 is the correct answer. So moving on to the next one, now we have question number 62, which is again related to the shape of the molecules, and we have to identify the incorrect match. So in the first option we have the molecule, that is HCO3. So if I draw the structure for HCO3, it has 3 sigma bonds and plus 1 lone pair. So the hybridization is sp3 and the shape will be pyramidal. So it is the correct option. And now we have ClF3, which is a very famous molecule. So in ClF3 we have 3 bond pairs plus 2 lone pairs. So the hybridization is sp3d and the shape is T shape. So this is also the correct option. So now we have XeF2 and I3 negative. In XeF2 we have 2 bond pairs plus 3 lone pairs. So the hybridization will be sp3d and the shape is linear. But the given shape is square planar. So this is absolutely incorrect. Now we have I3 negative. In I3 negative also we have 2 bond pairs plus 3 lone pairs. So So the hybridization will be sp3d and the shape is linear. So this is absolutely correct. So the only incorrect match is option number 3. So moving on to the next one now, we have question number 63, which is related to the critical constants. So we have been given that if Tc and Pc, that are critical temperature and critical pressure, of 1 mole of gas are 800 Kelvin and 82 atmosphere respectively, then the critical volume, that is Vc, is equal to. So for this you have to remember the relation, that is PcVc is equal to 3 by 8 R Tc. So now you have all the values, so substitute all the values and then you can get the answer for critical volume. So Vc will be equal to 3 by 8 R Tc divided by Pc. So 3 by 8 into R, so Tc is 800 Kelvin divided by Pc, that is 82. So it is 300 R by 82. So out of the following 4 options, option number 3 is the correct answer. So moving on to the next one now, we have question number 64, which is related to the formal charge. So the formal charge of nitrogen atom in Lewis dot structure of NH4 plus S. So first of all, how do you calculate the formal charge? So formal charge is equal to total number of valence electron in the free atom minus total number of non-bonding electrons which are present as lone pairs minus half into total number of bonding electrons. So this is the formula for the calculation of formal charge. So now you have been given for NH4 plus. So NH4 plus का अगर हम structure बनाएं, so it is the structure for NH4 plus. So you can calculate the formal charge very easily. So number of valence electrons in the free atom, that is on nitrogen. So valence electrons are equal to 5 minus total number of non-bonding electrons, they are equal to 0 as the all electrons are used up in the bonding. So 5 minus 0 minus half into total number of bonding electrons. So as you can see here, the total number of bonding electrons are equal to 8. So it is 5 minus 4, which is equal to plus 1. So the formal charge of nitrogen atom is equal to plus 1. So option number 3 is the correct answer. So using this formula, you can calculate the formal charge on any atom in any molecule. So moving on to the next one now, we have question number 65, which is again related to the hybridization. So it says that which reaction involves a change in hybridization of underlined atom. So in the first, we have the conversion from BF3 to BF4 negative. So if I draw the structure for BF3, you know that it is trigonal planar in shape, or as 3 sigma bonds are present, so the hybridization is sp2. But when it is converted to BF4 negative, the total sigma bonds are equal to 4. So hybridization is sp3. So there is the change in the hybridization of the boron atom from sp2 to sp3. So this option is correct. Now we have the second option, which is the conversion from H2O to H3o plus. So water, you know that it contains 2 sigma bonds and 2 lone pairs. So hybridization is sp3, and when it is converted to H3o plus, means one lone pair is being donated to H. So here 3 bond pairs are present plus 1 lone pair. So hybridization will remain same, that is sp3. So there is no change in the hybridization. So this is incorrect option. Now we have the third option, which is conversion from PCl5 to PCl6 negative. So if I draw the structure for PCl5, so it has 5 sigma bonds, so hybridization will be sp3d. And if I draw the structure for PCl6 negative, so there are 6 sigma bonds, so the hybridization will be sp3d2. So there is the change in the hybridization in the third case also. So the option number 4 will be the correct answer. So moving on to the next one,